Let's look at some nonlinear simultaneous equations. Nonlinear simultaneous equations. So what is that? So simultaneous equations is what we say we've got more than one equation, a system of equations, let's just say. So if you're looking at the first question here, we've got two different equations. So we have a system of equations or simultaneous equations. The word linear is used to describe an equation where everything only appears to the power of 1. So anytime you see an x, it's just x to the power of 1. Anytime you see a y, or whatever the letter happens to be, it only appears to the power of 1. If you see something like an x squared, or a y squared, or a root x, or an x cubed, or an xy, or anything like this, any combination of these terms, then it's nonlinear. Remember, it's only going to be linear in this scenario here, where you just see an x to the power of 1, or a y to the power of 1. So that's the explanation of what linear and nonlinear means. So looking over here at question 1, you can see that this first equation here, this is linear. The first equation is linear, and the second equation is nonlinear because of the squares and stuff. So this is the question that I'm going to do for you guys to begin with. So the method we use is the method of substitution. All right, that's the method you generally use if you have a system of equations where at least one of the equations is nonlinear. So let's have a look. We've got x plus y is equals to 3, and x squared plus y squared is equals to 5. So how are we going to do this? What we're going to do is we're going to take the first equation. We're going to take, by the first equation, in this case, I mean the linear equation. The first equation happens to be the linear equation this time. So we take the linear equation, the one without any squares, and we're going to rearrange it a little bit to either get x on its own or y on its own, whichever is easier. So in this particular case, I'm just going to isolate y. So I'm going to rearrange my linear equation and say y is equals to 3 minus x. So I've just rearranged that equation and I got y is equals to 3 minus x. So then what I'll do is I'll take the nonlinear equation and I'm going to rewrite it. And what I'm going to do is, instead of this term, instead of this y right here, I'm going to substitute in 3 minus x. That's why we call it substitution. We're going to substitute in the 3 minus x in for that y, and it will simplify the nonlinear equation for us. So let's rewrite this nonlinear equation. X squared plus, and instead of y, I'm calling it 3 minus x squared is equals to 5. Now what this has achieved for us is we now have a nonlinear equation with only one variable, just x's. So this is going to be a lot easier to solve than a situation where we have x's and y's. So we've rewritten the nonlinear equation to just have x's. So we'll continue on with this. We've got x squared plus, now 3 minus x to be squared. Let's be careful here. Let's go to our rough work and just be careful when we're doing our 3 minus x to be squared. So 3 minus x to be squared. Remember, that means it's 3 minus x multiplied by itself. So you've got your 3 by 3 is 9, minus 3 by x is minus 3x, minus x by 3 is minus 3x plus x squared. Tighten that up, 9 minus 6x plus x squared. So that's what we get when we square out 3 minus x squared. So we've got 9 minus 6x plus x squared equals 5. So we have our equation and we're getting there. So tidying up a bit further, you've got 2x squared minus 6x plus 9 minus 5 equals 0. So in other words, 2x squared minus 6x plus 4 is equals to 0. Now this particular quadratic equation can be simplified a little bit before we try to solve it. So we're going to divide the equation by 2 just to simplify it. When we do that, we got x squared minus 3x plus 2 is equals to 0. So continuing on, x squared minus 3x plus 2 is equals to 0. Factorizing that, 2 and 1. So this part should be straightforward enough for all of us. So you've got x is equals to 2 and x is equals to 1. Now the thing we have to be careful here is we're not finished yet. I see a lot of people thinking they're finished now, right? Remember, this was a system of equations, simultaneous equations. We had x's and y's if we go back. So what we have to remember is for each of the x values, for each of these x solutions, there is a corresponding y solution, and we need to go ahead and find that. So looking back, we had y was the same thing as 3 minus x. Y equals 3 minus x. I'm going to use that now to help me out. Y equals 3 minus x. And this would allow me to get my two solutions. So in the first case, when x was 2, we can say y is equals to 3 minus 2, y is equals to 1. So that gives me the solution x is equals to 2 when y is equals to 1. And then in the second case over here, we had x is equals to 1. So we'd have y is equals to 3 minus 1, y is equals to 2. So the solution in this case is when x is equals to 1, y is equals to 2. So that's one example. Let's look at a slightly more difficult example. All right, so we'll have a closer look here. I'm going to do for you guys question 8. Slightly more difficult than the previous example, but all the same philosophies apply. So let's get this question written up here. X minus y is equals to 8. X squared plus y squared. What do we got? Minus 6x plus 6y plus 14 is equals to 0. Right. So, same idea again. Let's start off with the linear equation and rearrange it. So in this case, I'm going to say x is equals to 8 plus y. And then, anywhere I see an x, like here and here, I'm going to substitute in my 8 plus y in for my x. So, rewriting the nonlinear one, instead of x squared, I'm calling this 8 plus y to be squared, plus y squared, minus 6 times 8 plus y. Notice I have no squared on the bracket this time because, as you see, this wasn't an x squared, it was just an x, so therefore there's no squared here as well. Just be careful about that. Plus 6y plus 14 is equals to 0. So same again, we're going to expand these brackets. So I go to my rough work to do that, just to keep the page tidy here. So let's have a look. We've got 8 plus y to be squared. We know that that means 8 plus y multiplied by itself. So you're going to have 64 plus 8y plus 8y plus y squared. In other words, 64 plus 16y plus y squared. So that's what I get for the first part here. 64 plus 16y plus y squared. So that was just the first bit. So just the first bracket. So then I have my plus another y squared. And then you've got your minus 6 into the bracket. Leaves me minus 48 minus 6y. Then I have my plus 6y and my plus 14 equals 0. So a lot of tidying up to do here. So when I tidy all this up, I'm going to have 2y squared. Then in the y's, 16y minus 16y plus 6y. So that's simply plus 16y. And then I've got my 64 minus my 48 is 16 and 14 is 30 is equals to 0. Now once again, we can see this equation can definitely be simplified if we divide the whole thing by 2. So let's do that. So we'd have y squared plus 8y plus 15 is equals to 0. Then I can solve it. Y plus 5, y plus 3 is equals to 0. So just continuing on from there. Y plus 5 is equals to 0, or y plus 3 is equals to 0. In this case, y is equals to minus 5. In this case, y is equals to minus 3. Now, once again, we remember that we're not finished. For each of those y values, we have a corresponding x value. So let's go back to the first page. And what I'm going to use is the fact that x is equals to 8 plus y. Alright, x is equals to 8 plus y. This is the important thing for me. So bringing that over, x is equals to 8 plus y. And I have the first scenario, when y is equals to minus 5, that means x is equals to 8 plus minus 5. So x is equals to 3. So that means when x is 3, comma, y is minus 5, that's one set of solutions, minus 5. And then similarly, when y is equals to minus 3, we get our corresponding solution. X is equal to 8 plus minus 3. So x is equals to 5. So this solution therefore is x is equals to 5 when y is equals to minus 3. So that is how you approach nonlinear simultaneous equations. So the best thing for you guys to do now is have a look at some more of these questions. The last couple are nice. These ones here are quite challenging. And please subscribe for more detailed and worked solutions.